Hi there, Algebra 2B, and welcome to the first part of Unit 7, the review. We're going to break up this unit and review it in different parts here. So just a few problems to remember how to do some of these problems here. So way back, first part of this was just rewriting expressions in exponential form. Remember, we could go from a radical form, that's what these are in, to an exponent form. Basically remembering that 3 is going to be our base. Okay, 4 is going to be the number in the numerator of the fraction. And divided by 3, okay, the radical index is the denominator. So 3 to the 4 thirds. And that's really it. That's all I'm looking for you to be able to do is write that in exponential form. Okay. For something like number 2, square root of 7 to the 5th, don't let the parentheses really throw you off. It's going to be the same thing. 7, this time to a power of 5. Now remember, with a square root, there's an imaginary 2 there. So it's 5 over 2, not just 5 over 1. It's not 7 to the 5th, obviously, because we have a square root there. So 7 to the 5 halves. And if you type those into your calculator, your graphing calculator, you should get the same thing for each of them. So that's a nice little way you can check. So if we would have taken parentheses square root of 7 to the 5th, whoops, outside the parentheses, we get 129.64, and if we take our 7 to the 5 halves, we should get the same thing, and that means we did it right, okay? Reversing, going backwards, okay? Same idea, only backwards. So 3 is going to be inside the radical. The 5 is going to be the power either inside with the 5 or outside, it doesn't quite matter. And the index of 3 is here. So just to follow with colors, this 3 is the index, the 5 is inside. You can also represent it as cubic root of 3 to the 5th. Okay, either way is fine. Doesn't quite matter to me. And for something like number 4, 3 inside, 4th root, and 5 outside. Okay, so hopefully pretty easy stuff. Just switching back and forth. You can use your calculator to check some of those. Evaluate. That's another thing your calc can do. You should have the TI-84 app from self-service. You can also download at the website at texasinstruments.com. Texas Instruments. Texas. Why Texas? I don't know. Otherwise, just type it in 81 to the 3 halves. You can probably even do it in like your phone calculator or something. What am I doing? 81 to the 3 divided by 2. Sorry about that. Make sure you do have the parentheses around the 3 halves. And you get 729. So no shame. Use your calculator. That's okay. 81 to the negative 3 halves. Okay, so let's just be careful with that. It's not going to be, okay, just a negative. Let's throw it in there. 3 divided by 2. So we get a decimal, but remember that really it should look similar because all it is 1 over 729. So negatives mean fractions when they're with the exponents. So negative exponents are fractions. Okay? So 1 over 729. Fraction is how you should represent that. Okay? Simplify the following. Leave no negative exponents. Basic idea is for numbers that are just regular old numbers, coefficients, we'll multiply those. So 2 times 2 is 4. We have multiplication. Just remember for exponents, we're going to add. So n and n to the 7/4, this is really n to the first. So add the exponents if they're on the same plane here. So 1 plus 7 over 4 is 2.75. Write it as a fraction, so 11/4. So 4n to the 11/4. Okay, that's how you'd represent that one. Right across, number 8, same idea. Multiply the 2 and the 3 is 6. If you add then the exponents of the p's, 3 divided by 4 plus 1 over 2. And if you know what to do in your head, fantastic. Or on paper, 5/4. So that's p to the 5/4. Okay, great. The next ones are power to a power. In this case, so notice we don't have multiplication, we have it raised to another power. You're going to multiply. Okay, multiply. And that's for, just to be specific, this problem. 1/3 times 2, that's just 2/3. And to the 2/3. And for number 10, okay, 4/3, again, multiply. Really, you're just multiplying the numerator times the numerator and the denominator times the denominator. But if things can simplify, you should also do that. So 4/3 times 3/2 is 2. Why? Because it's r to the 12 over 6, which is r squared. So reduce as much as possible. Okay. Probably the most challenging parts are adding and subtracting radicals. Remember, as long as the radicals are the same, you can add them together. What I recommend doing is simplify first. So let's simplify first. Simplify. I shared a link with you guys on Schoology, nth root calculator. If you go to that, it'll make your life much easier. I know sometimes cubic roots are tricky. You're thinking what times itself 3 times goes into 16. I don't mind. If you use this, it'll be very helpful for you. So 3 roots of 2 does not simplify anymore. You can even type that in here, 3 and 2, and hit simplify, and do. And there's our answer there, 1 cubic root of 2, okay? Not this part. For some reason, this is your actual answer. So it's just negative cubic root of 2. Now where this is helpful is, so if we just go back, let's just go back. And cubic root of 16, simplify. Okay, so again, that's not your final answer, not 16. It's down here, 2 cubic roots of 2. Now, where does that come from? And I'll show you with the next one. So negative 2 cubic roots of 2. That comes from, if we think of 16 as the cubic root of 8 times the cubic root of 2, well, the cubic root of 8 is 2, and then we have the cubic root of 2. So this is the same thing. That should be 2. And minus 3 roots of 2. So now notice that they're all the same radical. Square root 2, square root 2, square root 2. Which means we can just add the coefficients. Okay? Negative 3 minus 2 is negative 5. Minus 2 is, this is not a negative 3, sorry. That's a negative cubic root. Let me catch that. So negative 1 minus 2 is minus 5 cubic roots of 2. My fault, but I caught it there. All right. Number 12. So simplify first. So let's take the 4th root of 32. Again, whoops. You can certainly use our new friend here, little calculator. And it's not, I mean, it's kind of a shortcut. but I'm mainly concerned with, do you guys understand that we can add similar roots? Okay, 2 fourth roots of 2. Again, this part down here is the answer. So negative 2 fourth roots of 2 minus, it's the same thing, 2 fourth roots of 2 and minus the fourth root of 2. It doesn't simplify more. So what do we have? We have root of 2, root of 2, root of 2. Negative 2 minus 4 is negative 8 fourth roots of 2. Alrighty. Last two examples here. 6th root of 3, 6th root of 3, 6th root of 6. So they have to have the same index and the same number inside, which these two have. They don't simplify, so I just have 2 6th roots of 3. The 6th root of 6 still does not simplify. I know someone's probably like, that's 1. It is not 1. It's just the 6th root of 6. Okay, so let's just double check. 6 root of 6. Simplified answer is 1 6th root of 6, right where my middle pointer is. Okay. Last example, same cubic roots. Cubic root of 2, and then plus cubic root of 3. These two are the same because these are the same. Index and number inside. So I have plus 2 cubic roots of negative 3. Okay, so I know it's been a while. I shared some helpful tricks with you. I recommend using those. Okay, so web math, it's a simple radical calculator. Use the link. Also, make sure you have your graphing calculator links. But good job, guys. Thanks for doing those. Part 2 will be coming up shortly.